So we're in activity 4.3, multiplying to create polynomials. You can multiply to determine whether a product written in factor form is equivalent to a quadratic or cubic function written in general form. Consider, for example, a cubic function f of x equals 3x cubed plus 16x squared plus 12x minus 16. Is the function equivalent to g of x equals x plus 2, parentheses 3x minus 2, x plus 4? Go ahead and analyze the worked example for the multiplication of three binomials. All right. How can you use graphing technology to verify that the expression in factor form is equivalent to the product in general form? So we're going to graph f of x and g of x and see if they are the same. Okay, so let's go ahead and do that. Okay. So we're going to graph 3x cubed plus 16x squared plus 12x minus 16 and parentheses x plus 2 parentheses 3x minus 2 parentheses x plus 4. You can see that they are the same graph, and here are the zeros. Okay, so both functions create the same graph. How does the cubic function demonstrate the fundamental theorem of algebra? Explain your reasoning. The cubic function has 3 x-intercepts, or 3 zeros. All right, let's take a look at the next page. Teacher works 2a and 2b, and the student works 2c and 2d. Determine each product algebraically. Show all your work and then use technology to verify your product is correct. Finally, sketch the graph and explain how the function demonstrates the fundamental theorem of algebra. All right, let's take a look at A. So first, we FOIL here. X times negative 3x is negative 3x squared. X times 2 is plus 2x. 2 times negative 3x is negative 6x. 2 times 2 is plus 4 times 2x plus 1. Okay, now let's simplify this. That becomes negative 3x squared minus 4x plus 4 times 2x plus 1. Now we FOIL here. So negative 3x squared times 2x is negative 6x cubed. Negative 3x squared times 1 is minus 3x squared. Negative 4x times 2x is minus 8x squared. Negative 4x times 1 is minus 4x. 4 times 2 is plus 8x. And 4 times 1 is plus 4. Okay, so then that simplifies to be negative 6x cubed minus 11x squared plus 4x plus 4. All right, now let's graph and see if these are equivalent. So, parentheses x plus 2, parentheses negative 3x plus 2, parentheses 2x plus 1, and negative 6x cubed minus 11x squared plus 4x plus 4. You can see that these are the same, and then here are our zeros. All right, so let's use our zeros to sketch a graph. Negative 2, let's just put it here. We're just sketching. Negative 0.5, let's put right here. And 0.7, let's put here. Okay, let's go back to our graph. We can see it's coming down, back up, and back down. So, there is a sketch of your graph. velocity. We can say that there are 3 distinct zeros. Okay, go ahead and finish up 2a. All right, let's take a look at 2b. So let's FOIL. X times 5x is 5x squared. X times 1 is plus 1x. 2 times 5 is plus 10x. 2 times 1 is plus 2. So this is 5x squared plus 11x plus 2. All right, let's go ahead and graph to see if they're the same. So parentheses x plus 2, parentheses 5x plus 1, and then 5x squared plus 11x plus 2. You can see that they are the same, and here are our zeros. So to sketch a graph, we're just gonna let's put -2 here, -0.2 here, and then double check our graph so we know it goes like this. Okay, and we can say there are 2 distinct zeros. All right, go ahead and finish up 2a and b. And then start 2c and 2d. All right, let's take a look at the next page. All right, you can mark these off. Go ahead and read B. So how many x-intercepts does the function f of x equals x plus 2 cubed have? How many zeros? Count it with multiplicity. Explain your reasoning. The function has only one x-intercept, -2, 0. Since it crosses the x-axis only once, the function has 3 zeros. The 0 x equals -2 is a multiplicity of 0 with a multiplicity of 3. All right, let's take a look at the next page. Student works 1a. Student works 1b. All right, go ahead and mark that off. Student works 1a, 1b, 1c, and 1e. And then mark that out. And then student works 2a, 2b, and 3. All right, go ahead and start working on your assignment and have a wonderful Wildcat day.